The World Health Organization has just declared that an Ebola outbreak in the Democratic Republic of Congo is spreading rapidly. The immediate reaction from most observers is to view this as a humanitarian tragedy requiring urgent medical aid. But if you look past the headlines, the real stakes are far more complex and involve a direct trade-off between public health containment and global economic stability. By the end of this analysis, you will understand why stopping this virus requires dismantling an entire mining corridor economy, creating a strategic dilemma where inaction may be as dangerous as action. To grasp the gravity of the situation, we must first look at the numbers on the ground. Current data from the Centers for Disease Control and Prevention confirms there are 744 suspected cases, with 176 deaths attributed to this specific outbreak. These figures represent a human cost that is undeniably tragic, yet they also signal a far deeper structural failure. The virus in question is the Bundibugyo strain, which currently has no available vaccine on hand for rapid deployment. Without an immunological shield, the only tool left for containment is isolation and movement restriction. This creates an immediate friction point with the region's economic engine. The Democratic Republic of Congo possesses some of the world's most critical mineral reserves, specifically cobalt and copper, essential for global electronics and green energy infrastructure. These resources are extracted in a dense network known as the mining corridor, spanning Ituri and Kivu provinces. This area functions less like a traditional rural community and more like a high-bandwidth data pipeline where human labor is the primary transmission medium. The workforce here is not static. It relies on transient, non-resident employees who move constantly between remote extraction camps, processing hubs, and transport networks to reach global ports. Here is the thing that creates the strategic vulnerability. These movement patterns are architecturally identical to how a virus spreads through a network. When public health officials recommend standard containment protocols like roadblocks or quarantines to reduce the basic reproductive number of the disease, they are effectively introducing artificial latency spikes into this economic pipeline. In data engineering terms, you cannot stop the flow without crashing the system. The moment strict lockdowns are imposed in these provinces, cobalt and copper logistics grind to a halt because there is no alternative route for labor or goods. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This brings us to the core of the geopolitical dilemma. If authorities enforce quarantine measures aggressively based on historical data from 1995, which showed that rapid public health measures could have epidemic size, they risk collapsing the local economy entirely. A collapsed mining corridor does not just mean lost revenue, it means fueling the very instability and desperation that drives spillover events in the first place. Economic collapse creates power vacuums where armed groups thrive, making surveillance impossible and allowing the virus to spread further through chaotic movement rather than controlled transit. The situation is compounded by a critical blind spot in how we monitor these regions today. Surveillance infrastructure within the mining sector is siloed from public health systems, creating what looks like legacy system integration failures seen in distributed computing environments. Rapid spillover events often begin deep inside remote mining camps where edge connectivity and power reliability are non-existent. Because there is no real-time digital surveillance network capable of reporting these early signals to a central authority, outbreaks go undetected until they breach the transport networks and reach major towns or border crossings. This architectural gap means that by the time the World Health Organization confirms rapid spread, the pathogen has already embedded itself in the supply chain logistics. The velocity of this outbreak is not just a function of biological transmission rates, but is directly tied to the industry's reliance on high-mobility labor forces who act as vectors between infected zones and global markets. Standard containment protocols cannot isolate the pathogen without halting the extraction economy entirely, turning what should be a localized health crisis into a potential supply chain disruption for the entire world. The failure mode becomes clear when we consider the incentives at play. Global powers depend on this mineral flow to maintain their own technological and military capabilities. Therefore, there is immense pressure from international markets to keep these corridors open regardless of the risk level. This creates a situation where economic incentives directly conflict with the quarantine isolation protocols required to stop transmission. States are forced into a choice between immediate containment or long-term economic collapse. This dynamic mirrors lessons learned during the 2014 epidemic regarding digital surveillance networks. The experience showed that centralized cloud-dependent models fail in environments lacking reliable infrastructure. Future containment strategies must prioritize decentralized, low-bandwidth reporting architectures rather than relying on systems that require constant high-speed connectivity to function. Without this shift, every outbreak will be treated as an isolated medical incident until it has already become a systemic economic threat. The tragedy lies in the fact that there is no easy lever to pull. You cannot simply deploy more vaccines because none exist for this strain. You cannot rely on traditional quarantine methods without triggering a humanitarian and economic disaster of your own making. The region's mining infrastructure facilitates viral transmission through its very design, turning high-mobility labor forces into an unavoidable vector for global spread. This means the outbreak is not just spreading in Congo, it is spreading because the system that extracts resources from there makes containment impossible without total shutdown. We are witnessing a classic case of strategic vulnerability where the solution to one problem exacerbates another. The trade-off between stopping the virus and saving the economy forces actors into a position where doing nothing allows the disease to spread, but acting decisively destroys the local stability needed to sustain any health intervention at all. This is not merely a medical crisis. It is a test of how global systems handle critical infrastructure failures when human biology intersects with industrial logistics in high-risk zones. The path forward requires acknowledging that this outbreak cannot be solved by medical teams alone. It demands a fundamental redesign of how we monitor and manage these corridors, integrating health surveillance into the logistical fabric itself rather than treating it as an external constraint. Until such integration occurs, every attempt to contain the virus will continue to collide with the economic realities that drive its spread in the first place. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.